everyone. I will wait at least 30 more seconds to have everyone come into the webinar. All right, so welcome everyone. Welcome to today's summer preview day on the Student Ambassadors Undergraduate Research. So my name is Hanif Cropper. I'm one of the Assistant Directors of Admissions at Rensselaer. We have 3 students today that will talk about their research and their experience. After the 3 students talk, we have a list of questions that students ask beforehand. If there are additional questions, please write them in the chat, and we'll get to those after our listed questions. So I will hand it off to the students at this time, and again, they will talk about their research, and we will open it up with questions.
Hi everyone, my name is Luke. I'm actually just graduated about a month ago with my bachelor's in mechanical engineering, and I'm staying for my master's here at RPI. I'll be graduating in December. Originally it was going to be May. I had an internship lined up this summer, but that fell through, so I'm taking classes this summer into the fall as part of the co-terminal program. So for those of you not familiar, it's our 5-year program. So you only have to stay 1 additional year after your bachelor's, and any financial or merit aid transfers over to this 5th year. So it worked out very well for me. So I got involved with research during my sophomore year. I kind of knew from the beginning that I always found research interesting. But sophomore year was about the time that I felt I was ready. So I looked on RPI's website on the mechanical engineering department, and I found a professor who I thought was doing really interesting research. I didn't have her for any classes. She didn't know of me, but I sent her an email anyway, kind of a shot in the dark. Sure enough, the next day she replied, and I was in her lab like that. So it worked out really well for me. What we do in this research lab is a lot of computational modeling for biomedical systems, so kind of on the line between mechanical and biomedical engineering. During my undergraduate years, I worked on 2 projects mainly. The first was using CT scan segmentation to model the geometry for a trachea, and then use that 3D computer-aided model in computational fluid dynamics software to model airflow through the trachea. The second project was looking at the left atrium of the heart. Specifically, we looked at how the left atrial appendage affects blood flow in the heart. So we changed the geometry of the left atrial appendage. There are different types of left atriums. So we looked at all different options to see how blood flow patterns and things associated with that, such as shear stress and many other things, change with this resulting geometry, again, using computational fluid dynamics software. And the project I've started now that I'm going to be doing for my thesis has to do with the coronary artery. Again, this started as a CT scan segmentation. So I took CT scan models, made them into a geometry, edited the geometry a little bit to make it ready for the computational fluid dynamics software, bringing it into the software and modeling blood flow through this coronary artery. For my thesis, I'm going to be looking at a bunch of different conditions that the coronary artery could be in. So obviously healthy condition. We have a geometric or a finite element model for modeling stenosis. So stenosis is when the coronary artery collapses a little bit. So after that, we bring that back into the computational fluid dynamics software to see how blood flow changes. Then we do this with a stent implementation, and then restenosis, which is when it collapses again even after a stent is put in place. So it's been a busy summer. Will be a busy fall as I write my thesis looking at this project. That's kind of a brief overview of how I got involved with research and what my research interests are. So with that said, I'll turn it over to Lisa, who will explain her experience with research here at RPI.
Hi guys, my name is Lisa. I am going to be a senior this year. I'm another mechanical engineer, and I'm from Grafton, Massachusetts. And I've actually worked on 3 different research projects throughout my time, so I wanted to share a little bit about all of them. Although I am a mechanical engineer, I'm really passionate about the environment, and I want to learn more about specifically like ocean engineering. And I think after I graduate, I'd really like to do something where I'm making instrumentation to learn more about what's going on in the ocean and maybe in the atmosphere or anything in the environment, really. So I took an ecology class in the spring of my sophomore year, and my professor needed research done over the summer. And because I was doing summer arch, I was there that summer. So my first research opportunity was summer 2019. I assembled a virtual reality sandbox, and this is already made. I didn't do a whole lot of work for this. Like all of the programming and software was already done. I just had to kind of calibrate it and put it together. So it was a really nice like intro to research for me. It taught me a lot about kind of like how to troubleshoot when things don't go the way you want and to just be persistent with your research. And the whole point of this project was to be used for community outreach, because a certain amount of each professor's kind of funding needs to go directly back to the community. So this is a great kind of piece that's very interactive. So what happens is when you run your hands over the sand, there's a topographic map, and as you move the sand around, it updates. So you can use it to kind of just play around and see kind of where water will flow. And you could also use it for like elementary school aged teaching on like watersheds and how water flows in and out of rivers and from mountaintops down below. So that was a very cool experience. And then my fall of, I guess, junior year now was my arch semester away. And so I went to the University of New Hampshire in their Center for Coastal and Ocean Mapping. And I built all by myself, an independent project, an echo sounder, which is a sonar device. So it could test and basically determine the depth of water up to about 100 feet. And so this was completely new to me. I hadn't taken the electronics class yet, so I had to teach a lot of it myself. And I was working on it by myself, so I didn't really have a friend to reach out to and say, hey, how do you think about this? So it taught me a lot about how to be independent and how to teach myself new things. Because obviously when you're taking classes, you learn so much from other people, but this was a nice opportunity to kind of say, okay, I really need to sit down and think about what I'm learning. And so I was able to test this. The second picture is me on the day that we tested at sea. I mounted it onto the bottom of their Gulf Surveyor, and we were able to do a bunch of tests. And it was pretty accurate for a low budget 4-month-long project. So I was really pleased with how that turned out. And so after that project, I really was like, man, I really want to do something in the water. I want to do something ocean related. So I went back to my ecology professor and I said, hey, RPI has a project up at Lake George. Is there anything I can do for them? And he said, I know so many people you can talk to. So I'm starting this summer and really going to start in the fall a new project where I'm going to take a fluorometer, which is a device that has a little light on it, and it sends the light out, and chlorophyll, like algae, will absorb it and then give back a different wavelength of light. And so with that little measurement, you can tell how much chlorophyll is in the water, which is extremely important because you can use it to predict algal blooms, which are really not the best for lakes because too much algae will suck up so much oxygen that at the bottom of the lake there will be no oxygen left. So then organisms like fish who need the oxygen to go through their gills to breathe won't have that. So having too much algae is not a great thing. So this fluorometer, the problem with it is that because it relies on light, it gets a lot different, much more variance in recordings between the daytime and the nighttime, because during the day there's so much sunlight going around that the algae doesn't kind of like react as well to the light, and so at nighttime they have much more accurate readings. So I'm making a casing to an already known device, so that way you can pump the algae or the little microorganisms into the casing, and it'll be dark and it'll give the time for the cells to kind of relax, and then it'll take the recording. So hopefully we won't see that change in between the day and nighttime. And so this picture in the far right is a vertical profiler. These are all over Lake George. RPI is working along with IBM to make Lake George the smartest lake in the world. So we have these profilers that are all around the lake, and they have these little winches, and you can put any sort of instrument you want on it, and then it'll just every so often move the device up and down, and so it can take measurements all over the lake at different depths. So at the end of this project, I hope to be able to test this casing on the vertical profiler and see how it turns out. So I guess I haven't really learned a whole lot from this project yet, but what I have learned is, because I'm starting it over the summer, how to motivate yourself, because it's a lot more difficult to motivate yourself when you're kind of just doing it by yourself and you're not on campus. You don't have all the resources yet. So it's really been a new learning experience for me to try to start researching over the summer just by myself. But that's all of my research so far. Feel free to contact me and I'll be answering questions at the end. But now I'm going to pass it over to Jonathan.
Hey everybody! If you guys were joining me from the last webinar, it's me again. My name is Jonathan Bao. If you haven't met me before, though, I'm currently actually going to be a first year at Albany Medical College, so part of the Physician Sciences program here at RPI. In terms of where I'm from San Diego, California. Right now, I actually am not in San Diego. I'm actually in Albany right now. I'm kind of doing my research this summer and preparing for the start of medical school, which starts about in a month. So in terms of what I did at RPI, and I kind of split up my talk into little two sections. I have both research at RPI and at medical school. So I'll just kind of go into a little bit of both, kind of what I did and how I kind of went about getting it as well. So for RPI undergraduate research, I did one research, I researched in one lab at RPI, and that was with Dr. Ryan Gilbert. He's actually in the biomedical engineering department. So I'm actually a biology major. So again, just like Lisa, you can do research in other fields that don't necessarily are within your major. So in terms of the biomedical engineering research with Dr. Gilbert, I focused on developing biomaterials. So that's actually one of the focuses of biomedical engineering. There's I think there's two or three big focuses. One's biomechanics and one's biomaterials. I'm doing biomaterials. So what biomaterials are essentially, you can develop PLLA fibers or fibers made of these kind of these compounds that help either break down or redirect nerve growth. So in terms of my lab experience for biomaterials, we were spinning fibers that, in our research, have demonstrated that if you put neurons or other type of cultures on top of these biomaterials, they actually help regrow the fibers. So we are trying to develop next generation materials that help with peripheral nervous system injury and also central nervous system injury. And I started this research actually at this second semester of my freshman year. I'm a little bit unique in that sense that I came in with college with a lot of research experience. So starting early was not too much of a problem because I had the experiences necessary to go into that lab. But it was pretty critical, I think, that research experience really kind of solidified my interest in neuroscience. I've definitely been interested in that for a long time now, and it's something that I want to pursue in the future. But that lab experience itself was super, super helpful. So the whole branch of it is called neuroengineering in a sense. And then that research experience actually was really helpful in getting me my internship last year with NIH. I mentioned in the previous talk, but in that lab, I actually focused on doing more neuroscience research, but this time focusing more on the molecular bio aspects. So we were looking at the extracellular matrix, so the environment surrounding a lot of cells, and we found that certain proteins are upregulated in that environment that help actually promote growth, and some of them are actually very detrimental for nerve growth. So we were developing kind of understanding how and why these extracellular matrix proteins work, and so how they communicate and what the communication process was. So I actually did a lot of microscopy. It's pretty cool. But they have at the NIH, they have a lot of equipment. I would say like everything is a lot of the equipment that you see in labs around the country. NIH generally has it as well. And they also have a really big clinical center there that does a lot of clinical research. Honestly, super cool. Like that experience being in Bethesda, Maryland, and kind of being at the heart of research in um, the world actually was really cool. And in terms of medical school research, even if you're not part of the RPI program, you can actually do research at Albany Medical College. I had quite a few friends who were not AMC students who were doing research at with professors there. And research there, I would say, is both basic science and also a lot of clinical research. And also in people in between that do translational research, it really does vary depending on what you're interested in and what kind of offerings there are. Over there at medical school, I'm actually doing research with Dr. Julie Politzis. She's actually the chair of the Department of Neuroscience and Experimental Therapeutics, and also she's also a neurosurgeon as well. So she does research both basic science-wise and clinically. So I'm actually involved in both sides of that project. But the basic science project is actually what I've been doing a lot more of in terms of my thesis as part of my program. So in terms of the basic science, I'm working on developing a new treatment for chronic pain. So one of the pretty big treatment options that people don't really realize about chronic pain is that you can use neuromodulation. And neuromodulation is essentially using electrical signals. You can basically like give electrical impulses to the nervous system, and that in itself can actually cure a lot of chronic pain syndromes. That could be like failed back surgery syndrome, and also other neuropathic pains. And then on the other side of it, for the clinical side, we're actually studying spinal cord stimulation and dorsal root ganglion stimulation, also deep brain stimulation. These are also 3 neuromodulation techniques, and we're trying to kind of improve clinical outcomes for patients. Like, how can we improve their experience? How can we prevent failure of the equipment and things like that? And really just following up with patients, understanding how they work and everything. I think it's really cool. You don't have to necessarily get involved in that though. At Albany Med, a lot of the professors, you send them an email with your transcript or something like that, or your resume as well, and then they generally are very responsive. Aside from the neuroscience department, we also have a cancer therapy department there as well, and I think it's immunology as well, and also virology. Those are really big departments there. And so essentially what I'm saying is that if you can't find an opportunity at RPI, which I find very hard to believe, but if you want to find something else more out there as well, Albany Med is another option for a lot of students to do research at, and I would highly recommend it for sure, because the equipment there also is very high tech and also very innovative as well. But with that, I think that's basically my experiences. I'll be inviting the rest of the ambassadors back on now, and we'll be answering some questions. You can also, so we have some general questions on the last slide, but if you have questions that are like outside of that as well, you can actually put it in the chat box and we can answer those as well.
Awesome. So there are questions coming in the chat box, and I will approve them as soon as we get through the questions, the previous questions. So the first question, and any student can answer. The first question is, when will be a good time to start participating in research opportunities?
I guess I can answer this. It kind of depends per person, but what I will say is that when I was a freshman, I actually started out as a biomedical engineering major. And during the spring of my freshman year, I took cell bio, and I wasn't a big fan. So I switched over to mechanical from there. But that one semester, before I decided I was switching to mechanical, I actually did get involved in a research position in the biomedical engineering department. But that semester was really tough for me. I had a lot of difficult classes. So I didn't last too long in that research position just because I couldn't manage it. So my recommendation from that experience is figure out what you're interested in, make sure you have your time management skills down, then get involved with research. Don't mess up that order, otherwise
Right.
it
So
doesn't look pretty on
the
your
second
GPA.
question, kind of involving same thing, but is it recommended to focus on adjusting to the institute and the curriculum for a year or two before starting research? Yeah. Yeah.
Right.
Yeah, I
And
mean, that's
then
a very
the
similar
other
question,
question
but
is, what are some ways students find balance between their undergraduate research and classes? If there's any tips that you guys have.
For me though, I like to be busy, so I'm a little different. So I like to get involved in this as much as I possibly can in terms of what I'm doing. But in terms of finding balance, you definitely have to add. I would add it one by one. You would add like some like research on top of it, then clubs one by one, keep on going down the list until you have to hit a kind of a balance point, like where you realize if I do any more, I won't be able to kind of be able to go to class and do well at school. I think I'm not sure if anyone else has other suggestions.
Yeah, I think for me, I definitely chose to do research a certain amount of hours a week and stuck to that. So over the summer, when you have 6 week long classes that are a little bit more condensed than they normally would be, I was only doing maybe 4 hours a week of research, which is still not too much. It's like basically a class. So just making sure that for me, if I scheduled it into my time, then it was much easier to balance than just kind of having it looming over your head like, oh, I have to do this stuff.
And are there any specific robotic research programs?
yeah, actually, I can speak to that a little bit. I kind of accidentally got involved in a robotics program through my Capstone design course. So when I took Capstone, the way Capstone works here at RPI is a bunch of different engineering majors are in the same Capstone class. So my group had mechanical engineers, electrical engineers, but I know also industrial materials. Many other engineering departments are taking this class as well. And we pair up with a company either outside of RPI or kind of adjacent to RPI and work on a project kind of directly related to that industry. So the project I got put into was kind of through RPI. One of RPI's programs, or one of the RPI centers, CATS, the Center for Automation, Technology, and Systems, something like that. We had to, for our Capstone project, create a ergonomic teach pendant. So essentially a controller for these large manufacturing robots. So through that Capstone course, I got to work with them, but I know they take a lot of undergraduate students for just separate research projects as well. Okay. So yeah, kind of accidentally figured that out.
I am looking through the chat right now, and I'm just looking through certain questions. We can start with any advice for the students applying to the physician science program?
Yeah, of course, I got that. Okay, so in terms of the program, I would definitely recommend, especially in high school, most students in the program, actually not most, basically all students in the program are involved in research during high school. I would definitely say some people don't have the opportunity to do research, and so there's a lot, especially right now with COVID, there's a lot of opportunities for high school students to do like bioinformatics or like kind of like computational research. Those also count as experiences that are really important for the program. Another big thing is just getting involved with clinical work, like getting clinical experiences like volunteering, shadowing are all really important. And I guess the most important thing is keep your grades up. Those are really important. For students in the program, in order to succeed, you have to be very academically sound as well and be able to do everything before that. So definitely emphasizing that. And the second question I think is on biology major curriculum, so I can answer that as well. In terms of the bio curriculum, I can link it in the chat as well. But in terms of a quick general idea is, we have a lot of lab-based courses and also lecture-based courses. So lecture-based courses range from molecular biology to cell biology, and then in terms of we also have organic chemistry and other chemistry courses as well with lab-based courses tied in with. So I'll actually link the link to you right now, and then it'll probably answer most of that question.
All right. Okay, so what kinds of things did you do in high school to think or to help you with getting admitted into RPI?
I guess the big thing is just do well in your classes. Work hard, take challenging classes, especially in math and science, if that's what you're interested in. Obviously, doing extracurricular activities, whether it's related to engineering or science or not, is great too. But really just keep yourself busy, keep yourself active, work hard, and you'll have a good shot.
Sorry, just going through. Okay, so during research, were there different groups of people with different majors working together? Or is this mostly just bio students or engineering students?
I mean, I would say it definitely depends per lab. Obviously, first of all, I should mention that it's not just science or engineering students that have research. People in humanities, arts, social science, and any other one of our majors at our school have research as well. So I should say that to start. But secondly, even within labs, there's people from different majors can be working on a similar project. My lab has only mechanical engineers, but it can be arranged,
I think
for sure.
Most projects have to be multidisciplinary to a certain extent, because you can't, with more people and more knowledge from different areas comes, more in-depth and better products, right? So like for me, working in the ecology department, I'm working with kids who are environmental science majors and environmental engineers, and all sorts of that sort of stuff. But then I also go back to my own set of resources within the mechanical department to get their aspect and their point of view as well. So I think it is very multidisciplinary.
Okay. Okay, so is high school research experience required if we wanted to participate in research as a freshman?
No, but it definitely is helpful to get into labs, for sure. Because some labs, I would say, like some labs are competitive. They have a lot of applicants to go into that lab, and so for those type of labs, it is beneficial to have research experience. But then again, this doesn't apply for everybody. It's it's kind of different across different departments and things like that. So it would be helpful, but it's not necessary.
All right.
Can I also say that you can't start research until your second semester freshman year? So you also have a semester to kind of get some classes under your belt, but also look around at different research options. So that way, going into your second semester, if you really want to do something, you can kind of get ahead of the game.
Okay. And were any of you involved in high school research? And if so, how did that help you?
I was involved in high school research. So in high school, I did an internship after my junior year of high school. I actually worked at Scripps Research, which is an institution in San Diego. I actually worked on a pretty big molecular biology project there. I worked at that during that summer, during the school year of senior year of high school, and also the summer after senior year of high school as well. So coming in, that I learned quite a bit. I was very, very fortunate in that sense because that lab in itself taught me a lot of the skills and things I needed to come here. So it definitely was beneficial for sure.
Yeah, I did a little bit of research in high school as well. Towards the very end, the way my high school works is for the last the third trimester of your senior year, you do an independent project. So I'm near Manchester, New Hampshire. So I got a research position at St. Anselm College in the biology department. I looked at snake bites and motion tracking and things like that. So kind of out of left field, but still pretty interesting and still pretty relevant in terms of the research process, research methods, things like that. So even if the research you're able to find, which probably is limited in high school, even if it's not directly what you want to be doing, it's still great experience and will help you a lot in college.
All right. So the next question, it says, what percentage of students end up doing research before they graduate? I could answer this, but if you guys want to answer this, you can answer it as well. It's up to you. Okay, so on the admissions side, or just looking at the statistics, over 75% of students will participate in undergraduate research before they graduate Rensselaer. All right. There are many questions, and I'm just filtering through because a lot of them do overlap. So give me time just to read them through. If this question wasn't already answered, but how do you hear about research opportunities once at RPI? And how do you apply?
I mean, I think as you heard from all three of us, we all had different experiences getting involved with research. There's no one way to do it. It could be through a class. You take a class with a professor who, and during the class, the professor mentions they have some open positions, and you could ask them. Could be like me, just sending a random email out of the blue. There's a number of different ways. There's no one set way to get involved in research.
Yeah, I think.
If you're curious about finding out more, oh, go ahead.
Thank you. I think I've had like 3 or 4 professors announce at the beginning of the first day of classes, like, hey, by the way, I have a research lab if you want to apply. And you can also just go up to a professor who you find it interesting. So I think it's partially some sort of application process for those labs who are more intense or have more applicants. And then on the other half, it's kind of like just making connections with your professors. And it really just depends on the lab.
All right. So a question that I can see here for Jonathan. What is RPI looking for academically and prospective students for the BSMD program?
Okay, yeah. I would definitely say they were looking for a strong science-based curriculum, like in terms of grades and stuff like that, like taking a lot of science courses, like bio, physics, chemistry, things like that, like mathematics as well. Those are like all kind of generic, but in terms of like shadowing and like kind of all the clinical experiences, to give you an example of what some of the people in my program in my year did. So for me personally, I did about 400 hours of volunteering in a hospital. I shadowed about 150 hours if you the neurosurgeon, so I kind of got a lot of experience to know that the fact that I wanted to do it. Because I think for the program, people don't realize that is that you're kind of locking yourself into a career in medicine, and that for people like the admissions committees, they want to know that you are committed to medicine, that you want to do this as a career. So you have to show that commitment in that sense. And then for research, I saw a question above us about like publications, things like that. You don't necessarily need to have publications. I didn't have any to get in, but having the experience and the the know about how to do it is really important, I think, because you, as the program says, it's a physician scientist program, right? So you're both a physician and also a scientist, so you have to have that both sides of that kind of spectrum.
So the next question is, how do you handle the loss of interaction aspects during the online schooling in your second semester here? If any student has done a research online.
Yeah, I'll speak to that a little bit. I would say this vastly depends per lab. If your lab is more experimental and you actually need, a physical laboratory, yes, it's going to be a little bit more problematic. But for me, it really wasn't any different because all of my research is computer simulations. So there's really a huge range. For me, it was pretty straightforward. There really wasn't any difference with the pandemic. But obviously, there are a lot of people who have had to change trajectories or had to wait a little bit to be able to get into
this question can be for anyone. It just says here, how have you all motivate yourself during COVID-19?
I mean, for me, I think I mentioned this briefly at the beginning, but I originally had an internship, but it got canceled. So I decided to, take classes. I guess for me, the big takeaway from that is just to keep yourself busy, whatever that means. Yeah, that did mean adjusting my schedule of when I graduated and everything, which is kind of disappointing. But the best way to keep going is to keep yourself busy, keep yourself active. Don't dwell on the fact that you can't do anything. Just find something to do, whatever that may be.
Okay. Sorry, just reading. It says here, what was the biggest factor that caused you to choose RPI, and was it the research aspect?
I think for most students, although I can't speak for everybody, the greatest thing about RPI, or at least the most enticing thing, is the community. I don't think research was necessarily the thing that I was super excited about coming to RPI. However, I knew that I wanted to be at a STEM school because I liked math and science so much, and I knew that I would have better opportunities overall by going to a STEM school. But I think everybody really enjoys their experience here because of the community that RPI fosters. We're not cutthroat, but we are super collaborative, and we're really competitive in the sense that we all want to learn more. We all want to succeed and really strive to be the best, scientists and engineers and all of the majors that we have, the best that we can be, really. And so for me, I think that was the biggest thing, just the size of the school, all of the opportunities it offered, and the type of learning environment that I would be in was just exactly what I needed.
Here's a question. It says, any tips on things to know on publishing a research paper? I have a project that I already finished and I have a draft already.
Biggest tip is just get it reviewed and reviewed and reviewed. That's the biggest thing. Usually have in terms of writing papers, I write the paper first usually, and then I send it to my PI, whoever my mentor is, have them review it, and then they can send it back to me with comments. I go over their comments, send it back to them, send back another round of comments, and then I spread it out to whoever the authors are on that paper as well. So all these kind of ways help get it reviewed better and get it kind of really get it thoroughly checked out before you submit it. And even the submission process, they have reviews as well for your paper before they even accept it into their publication. So just in general, just make sure that there's no grammar errors, something like that. Those are the most obvious ones. But other things that you can look into are how to structure it and things like that, which are all really helpful with other people looking at it.
Another question here is, what are some examples of research opportunities available specifically to mechanical engineers? If you know of any.
Well, I mean, as you can see from me and Lisa, we're both mechanical engineers, but we took very different paths. And actually, both of our paths are very non-traditional to what you'd think of as mechanical engineering. So I can't necessarily list off everything that's available just within the mechanical engineering department, never mind any other research that mechanical engineers could get involved in. But anything you can think of, I mean, we have something you can get involved in here for sure, whether it's more traditional or kind of interdisciplinary. Mechanical engineers are in a great place to get involved with kind of any type of research. It's a major with a lot of different requirements, so you have a big skill set to bring to the table for any type of research you may want to get involved in.
Yeah, I think some of the big ones that come to mind are we have a professor who does friction research, and we have a lot of wind tunnels and thermodynamic, fluid dynamic labs, and also structural based labs. We actually have a lab course called Mechanical Systems Lab that's all about tensile strength of materials and how they're going to react under different circumstances. So there's a lot of pure mechanical stuff, but like Luke said, there's so much that you can do with such a versatile nature.
All right. The next question is biology related research mandatory for students considering the physician science program, or can other kinds of research can be considered as well?
I would say it can be a mix, honestly. I've seen people do physics research as well. It kind of varies, but definitely having the research experience is what matters the most because it's the mindset how to do it, right? I kind of know the scientific method, how to do hypothesis, things like that, are I think more critical.
And then the next question is, are there opportunities for independent research?
I mean, I know what you can do is you can go up to professor and ask them for an independent study. So it can be kind of like a course, could be more research based. Things like that are more open ended, so it's hard to actually say this is exactly how it works because by nature it's a little bit more open ended. But yes, any professor, or at least most professors here, would be more than happy to have a discussion with you if you have something in mind, and they can just kind of guide you in that direction. You don't have to specifically do a traditional research position necessarily. Again, that may involve talking to professors, figuring out how they can accommodate this, but from my experience, what I've heard, a lot of professors are more than happy to kind of push students in whatever direction they want to go into.
Also, with the summer arch program, for your semester away, one of the options is to do an independent learning experience. So if you don't want to do a traditional like internship or co-op or research opportunity somewhere else, you can choose to do an independent learning experience where you could do your own research, whether that be in a host lab or just by yourself, is up to you. But there's at least like a 4 to 6 month period that's kind of given to you to do that if you really want.
Thank you. And this question just says, can you please share your contact information with the student, with the panel? And I will do that as well right now. All right. Yeah, just by going through right now, a lot of the questions were answered. There has been a lot of overlap, so I'm not going to say, all the questions that are in here, but there have been a lot of overlap. If there are any questions that you just thought of right now, you can type them in, and we can wait to see if there are.
And if you think of questions after, by all means, feel free to email us. We're more than happy to help and answer questions. We were in your position at one point too.
Okay, there are more questions coming in. This question says, can you tell us more about your experience with the Arch program?
Yeah, I think I was the only one who did Arch here, right? So the summer Arch program was really fun. I keep getting like Snapchat memories from last year, and I'm like, man, I really wish I was back on campus. And I think it's kind of gotten a lot of mixed reviews, but a lot of that negativity has come from upperclassmen who haven't even participated in it at all. Arch was a really fun experience for me. I spent all of last summer on campus. I only took 12 credits, which is about 3 classes. So it wasn't too challenging. It was definitely a really fun opportunity to be able to hang out with my friends, enjoy the summertime because for the most part you're on campus during the winter months. So you're able to explore Troy more. I was able to go to Lake George a few times, which is about an hour away. And then in the fall, I did my semester away. And that was what I mentioned earlier about that echo sounder. And that was a really awesome experience for me too, because it was in a new area of New Hampshire. I'd never been there before. I'm from Massachusetts. I met a lot of new friends that I still hang out with or at least do Zoom calls with now. And so for me, it was a really positive experience. And I know that this summer is a little different because the students are taking classes online, but I think RPI is really trying their best to give them the opportunities as best as they can remotely. They're doing a lot of event planning and stuff like that, even though it is virtual. And then they are kind of with the COVID plan coming back, having most of their students do their co-ops in the spring, which is really beneficial because I think the fall doesn't look like it will get any better. So giving them the best opportunity they can to do in-person experiences is definitely the right mindset. So I think Summer Arch has been a really great experience for me and hopefully for the kids doing it right now.
Great. All right, so we have time for one more question just to state in the time. This question is for Jonathan. The question says, pursuing medicine within or outside of the physician science program, would you suggest seeking research at RPI or at Albany Medical College?
Okay, yeah, that question is a good one. So, for medical school, I think is what you want to do, right? Like, you have to be passionate about the research that you're like conducting and what you're interested in. And so, if it's not at RPI, definitely do it at AMC. And if it's at AMC or not at AMC but at RPI, I would do it at RPI because the biggest part about research is that you have to love doing it. If you don't love doing it, it's kind of like a chore, I would say. And research kind of defeats its whole purpose if it's just kind of a chore because it's not something that you're passionate about. And especially for like medical school, I would say like if you don't really like research, there's other ways to kind of show that you're interested in medicine, like whether it be doing additional clinical experience or something like that. But like research is something like for some people, I know for sure for all three of us on the panel right now, something that we really love to do. Like we want to find out more about why things work, and so I think it can be done anywhere. You can even be done in your own home if you have a bioinformatics program going on, like at some other university. You can do that as well. Like honestly, any type of research, as long as you are something you care about.
Great,
I think that's the biggest thing.
So I just want to say thank you everyone for attending. We are past our time. If you have more questions or you are typing in the chat box right now, just please give us a contact via the emails that are sent in the chat, and we will definitely get to you as soon as possible. Again, thank you so much, and thank you, panelists. I'm going to give you a round of applause. Thank you again, and please just send us an email if you do have additional questions. Thank you, everyone.
Bye-bye.
Thank you.
See you guys.